Here we have a sample NMR spectrum of this compound that we just looked at with the carboxylic acid and the alkyne. And a couple features to take out of this. First, you'll see that it runs from right to left, and it goes from 0 to 12 ppm or parts per million. Now this is a proton NMR. And in general, proton NMRs run from about 0 to 12 or 13 parts per million. That's pretty standard. Now, although it's not shown in this spectrum, at 0 you often have a signal for a standard known as TMS, and that's trimethylsilane. And that's your standard at 0 parts per million. And these parts per million values, we term these chemical shifts. And chemical shifts is often abbreviated using the Greek letter delta. So to the left-hand side of the spectrum, we have a high chemical shift, or high delta. To the right-hand side of the spectrum, low chemical shift. You also hear the terms shielded and de-shielded, upfield and downfield, associated with NMR spectrum. And what that is it's just essentially the left or the right-hand side of a spectrum. So to the left-hand side, we call this the downfield region. And that's because it's downfield from TMS, which is our standard. On the right-hand side of the spectrum, we call this upfield. The other associated terms, to the left-hand side of the spectrum is de-shielded. So if you have a proton that shows up on the left-hand side of the spectrum, like this carboxylic acid proton, it's said to be a de-shielded proton. Then protons that appear to the right-hand side of the spectrum, we call these shielded. So looking at this compound, the carboxylic acid has a high chemical shift above 12 parts per million, and it's quite de-shielded. And relative to the carboxylic acid, this hydrogen on the alkyne is shielded, and it's up toward the right-hand end of the spectrum, which is the upfield region. Also, if you want to think about this in terms of the RF frequencies, and going from right to left, you're increasing in the frequency.